Swayam Prabha. Digital India. Educated India.
In the previous lecture of rubber products, I was discussing about the different types of accelerators used for the vulcanization or cross linking of different rubbers, natural rubber or synthetic rubbers. There are large number of accelerators available for vulcanization of rubbers. Accelerators are used for the accelerating the reaction between sulfur and rubber. These are basically amine derivatives, and there are different classes of accelerators. Aldehyde amines, guanidines, thiazoles, sulfonamides, diethylcarbamates, thiourea sulfides, xanthates, thiocarboxyl sulfonamides. Now, their speed of reaction with sulfur in order to form cross-link bonds, sulfur cross-link bonds, they differ depending on their chemical formula, chemical structures, etc., and that is why there lies a proper selection of a suitable accelerator from this list of accelerators that is necessary. Someone is very fast accelerator, someone is slow accelerator, someone is medium fast accelerator, etc. Now, to tell about the accelerators once again little bit, we must say about the accelerator characteristics. We must know about the accelerator characteristics. Accelerators characteristics can be explained with the help of a rheometer trace. Rheometer trace, which makes a plot of torque in pound inch or Newton meter in any units versus temperature, versus time, curing time versus curing time. This is curing time. Basically, it is a torque time profile produced by one accelerator in a rubber compound. A rubber compound contains rubber, say for example, 100 parts per 100 per pHr, 100 pHr parts by weight, then filler that may be 50 pHr, then process oil that may be 10 pHr, then stabilizer, antioxidant or antioxidant that may be 1.5 pHr, cross linking agent, sulfur as the cross linking agent that may be present as 1.8 to 2 parts by weight. Then along with sulfur as the cross linking agent, that can be accelerators, say from that list I have shown CBS as well as MBTS combination or other combinations can also be used. So, say it is one part, it is suppose 0.8 part or more than 0.8 part, and some retarder can also be used. So, this can be a formulation using these accelerator or accelerator combination like this, and rubber can be natural rubber, a combination of natural rubber with synthetic rubber is styrene rubber, or natural rubber polybutadiene rubber, or SBR polybutadiene rubber. So, that depends on the type of product which is to be made. Anyway, I am showing you a general composition or formulation of a rubber product in which the sulfur and accelerators are present. If this accelerator is present, that accelerator decomposes to form some intermediate chemical compounds which form some complex with sulfur, that is known as sulfurating complex. That sulfurating complex produces some sulfur atom from the S8 ring of sulfur. That sulfur atom reacts with the diene rubber to form a cross-link bond. During such reaction, what happens? There will be intermolecular linkage between the linear polymer molecules through sulfur atoms like this, either disulfide or polysulfide SX or disulfide linkage, etc. So, that forms a 3-dimensional linkage through sulfur like this. So, that cross linking, during that cross linking formation, the mobility or the flexibility of the segments of in between two cross links are gradually changed with the introduction of more and more sulfur cross link bonds, and that actually manifests to the development of torque in that rheometer. This kind of rheogram is produced by a rheometer which contains a rotor which is connected to a motor, oscillating disc motor, oscillating rotation, oscillatory rotation is provided by that motor that oscillates at 1 degree or 3 degree arc, and that rotor is placed in a cavity, and over the rotor that rubber compound is placed, and two platens of that cavity are closed, and that platens are have some heating arrangement at different temperatures. It is a temperature controlled heating arrangement. That temperature is maintained at a vulcanization temperature of 140 degree Celsius or 160 degree Celsius or even 150 degree Celsius as per the requirement. This temperature is maintained, and as soon as the rubber is placed, what happens? The rubber compound gets heated, and slowly what happens? That the viscosity or the torque decreases due to increase of temperature. Then it becomes parallel to the time axis for some time. Then this torque starts rising. This torque increase or rising torque that happens due to the introduction of these cross-link bonds in the in between the rubber molecules, and ultimately it gives this kind of profile, torque profile with time at say for example, at say 140 degree Celsius temperature. Okay. Now, there can be another kind of curve which leads to this type of torque rising instead of becoming parallel to the x axis, time axis, or it can come down. These different cases can occur. This is known as a Cure profile or cross linking profile, and this is the characteristic of accelerator. Now, this characteristic of accelerator basically these are Scotch time and cure rate index, optimum cure time, this is marching cure, this is plateau, cure, this is reversion. And let us see what is scorch time. Now, when it is placed, the viscosity or torque decreases due to the increase of temperature of the compound. As soon as that compound sense this temperature of 140 degree, then it becomes parallel to the time axis. That means, there is no chemical change till this point. Beyond this point, some chemical change has started to occur and then torque starts rising. Means that compound is provided some restriction of mobility, that is a torque, it is oscillated, rotor is oscillated. So, that rotor experiences some opposing force towards its oscillation. That opposing force towards oscillation is contributed by introduction of these bonds. This starts here it is this introduction of such cross-link bond sulfur intermolecular linkage bond formation starts at this point of time. Then slowly the number of these such bonds intermolecular bond formation increases and this torque goes rising this way. That means, the curing reaction or cross-linking reaction has started over here and it is increasing at this rate. This is the this slope of this curve is the cure rate. The slope of the cure rate can be obtained from the slope of this torque versus time, these two parameters, the ratio of these two parameters gives the cure rate index. Now, the time required, now this is the maximum cure for this particular plateau effect. If we say this is the maximum torque, okay. So, time required to achieve 2% of the maximum torque, say T2 is known as scorch time. T2 is the scorch time, time required to achieve 2% of the maximum torque. Now, there can be T5 also, there can be T3, T4, that means, the time required to 2% of the torque, maximum torque, time required to achieve 5% of the maximum torque or 3% of the maximum torque or 4% of the maximum torque, that is known as the scorch time. That scorch time information can be available from this cure curve, that means, rheometer profile or cure profile obtained from a rheometer. Now, that information is necessary because that scorch time gives a scorch safety indication. What is scorching? Scorching is premature, scorching is premature vulcanization. What is that premature vulcanization? Now, because this rubber compound is prepared by mixing with filler, stabilizer, process aids, other things and sulfur, accelerator, etc. Now, during compounding, the compound temperature rises to beyond 70-80 degree Celsius. So, the compound should not start curing during such compounding. Not only that, after compounding, that rubber compound is used for fabrication of some so to give a shape of that product, say making a tire product or making a tube or making a profile. So, that passes through some machineries, say extruder machine or curing mold, curing press, etc. So, during that period, the compound should not start any premature cross linking. That means, the temperature rises. So, it should remain on cross link that at that temperature during processing and fabrication, that is known as scorch scorching. If that reaction starts there during fabrication, that is known as scorching or premature vulcanization starts over there, that should be prevented. In order to get that information, the scorch time information is very much important. That means, at this high temperature of 150 or 160, this T2 value gives an indication that till 150 degrees Celsius, only if even if some reaction starts, only 2% of this maximum torque can 2% of the crosslink can occur, or 1% of the crosslink can occur, or no crosslink can occur. So, this T2, this say T2 can be over here, and optimum cure time is known as T90. That means, the time required to achieve 90% of maximum torque, 90% of maximum torque, say mH. T2, this optimum cure time, optimum cure time OCT, and scorch time T2. So, this is 90% of maximum torque, this is 2% of maximum torque mH. This is mH. Okay. So, this is one parameter, this is one of the accelerator characteristic, and the curve can be, this curve can rise this way, or this can also rise this way, this can also rise this way, this can also rise this way. So, these are known as the character. How it actually this rubber compound starts curing or continues curing, that is known as that is the characteristic of the accelerator. That means, whether there is delayed action accelerator, whether there is slow accelerator, whether there is fast accelerator, whether there is scorchy accelerator, those things can be judged from this rheometer profile. If more information is required, the reader is referred to some special books on rubber technology, or vulcanization, or science and technology of rubber. Then after this accelerator accelerators, accelerator modifiers are also required in order to help the reaction between accelerator and sulfur. Now, there can be that those are known as accelerator activators. What are these? Now, accelerator activators are a combination of chemical compounds of oxides, inorganic oxides and organic acids. Among inorganic oxides, there are zinc oxide is the most common in all rubber industries, in all rubber products. Say in tire products, the zinc oxide is common ingredient as metal oxide activator, or in some cases hydrated lime can be used, litharge can be used, red lead can be used, magnesium oxide can be used, or alkali carbonates can be used, and some metal hydroxides can also be used. That means, basically these are alkaline materials, alkaline or neutral materials. Neutral, zinc oxide is neutral or alkaline materials. Along with these compounds, any of these compounds, some organic acid has to be used. That means, a combination of both metal oxide and organic acid constitute this accelerator activator. What happens? This metal oxide and organic acid form a salt during the vulcanization reaction within the rubber product. So, a combination of these two form a salt, and that salt interacts with the accelerator through chelate complex formation. Then that complex interacts with the sulfur to form a sulfuretic complex, and that releases sulfur atoms for making activated sulfur atoms, energetic sulfur atoms, that produces crosslink between the rubber molecules. Other than metal oxides, alkaline substances like ammonia, diethanol, diethanol or triethanolamine or amine salts or reclaimed rubber can also be used. One thing should be known from here at this point I must refer, that is the vulcanization reaction favorably occurs, is favorable at alkaline pH of the rubber compound. So, such alkaline pH is developed or maintained through the use of these alkaline substances. Although organic acids are used, since that forms salt with this thing, that cannot reduce because that cannot ionize. So, these cannot decrease the pH. So, in order to increase the curing rate, vulcanization rate, alkaline substances are preferable. So, ammonia, diethanol or triethanolamine or amine salts or even reclaimed rubber, which is alkaline, that can increase the curing reaction rate, vulcanization rate. So, we have discussed about the accelerators, accelerator modifiers, that means accelerator activators. Then there is another class of compound in the rubber product used, which is known as retarders. Retarders, or they are sometimes told as PVI. Basically this PVI is pre-vulcanization inhibitor. I was talking about the scorching reaction before final shaping and vulcanization. The scorching or premature vulcanization should not occur during rubber compound formation as well as during fabrication and shaping. Now, in order to increase the productivity of a rubber product, sometimes high speed accelerators are used, means fast accelerators are used. Now, those fast accelerators, what happens? They produce a cure profile, torque time profile, like this, very fast accelerator. That means, this time is very small and this gives steep rise of this curing rate like this. This small time is required for high productivity, that means vulcanization is complete over here. Say vulcanization should be completed within 5 minutes. In that case, one should use very fast accelerator. Now, if a fast accelerator is used, that fast accelerator should be compounded with proper care, otherwise that will scorch the rubber compound during compound formation or during the processing or shaping operation, during fabrication operation. But this is little difficult. So, use of fast accelerator is restricted there, but one can use provided if this region can be kept safe, even if this fast accelerator is used, that is done by the use of a retarder. That means, during compound formation in a mixer, say internal Banbury mixer or open mill for proper mixing and dispersion of the ingredients, the accelerator and sulfur should not start reaction over there, that can be kept dormant provided some retarder is used, by the use of some retarder. Retarder means that will retard the reaction, vulcanization reaction, that is called, or that will inhibit the vulcanization reaction. that is called pre-vulcanization inhibitor. Compounds like N-cyclohexyl thiothalamide, N-cyclohexyl thiothalamide or even phthalic anhydride, acidic in nature. I told you that acidic compound does not allow the cross linking reaction or slows down the cross linking or vulcanization reaction. So, acidic compound or this phthalimide type of compound or nitrosodiphenylamine, these compounds are used as retarders along with very fast accelerators. So, even if fast accelerators are used, if these PVI compounds are present, that will prevent this vulcanization reaction to occur during the compounding and fabrication period. That means, that retarder will provide some scorch safety maintaining the high cure rate, high vulcanization rate. That means, this is maintained, but this can be delayed this way. So, instead of this curve, one can get this kind of curve, but if some PVI is used. So, if PVI is there, here is no PVI in this case, no PVI in this case, there is no PVI, in this case there is PVI. So, this kind of characteristics can be available if some pre-vulcanization inhibitor is used. Anti-degradants. Now, after this pre-vulcanization inhibitors, I mentioned that stabilizers are used. The stabilizers say that can be antioxidant if the degrading agency is oxygen, of oxidative degradation of rubber product. Rubber products are exposed to air which contains oxygen. So, slowly oxygen will degrade the product. So, that degradation should be prevented by some compound, by the presence of some compound, so that the life of the rubber product is prolonged. Those are known as antioxidants. Now, if the degrading agency is ozone, now there are certain regions on the earth's surface, atmosphere contains ozone, higher ozone concentration. To prevent the product, rubber product from degradation by the presence of ozone in the air, in the atmosphere, that compound is known as anti-ozonant. There can be thermal agency. So, heat stabilizer, for thermal degradation. So, these are, in order to prevent the degradation by different agencies, stabilizers are used or anti-degradants are used. These are in effect called anti-degradants. Now, let us have a very quick look into the degradation mechanism of rubber. Now, RH represents a rubber hydrocarbon containing carbon-carbon linkage, containing unsaturation bonds, containing carbon hydrogen bonds. So, that is that rubber represented by RH. Now, somehow if there is some agency which attacks the rubber, that attack can produce some, say, rubber contains this carbon hydrogen bonds. I am showing only one carbon hydrogen bond. Now, that bond can be broken over here, forming a free radical. That is represented by here as R dot. This R dot is produced. Now, this R dot is very active. Now, if it gets access to oxygen from the atmosphere, that forms a peroxy radical, ROO radical. So, once this is initiated in a rubber product, on the surface of a rubber product, that gets access to oxygen in the atmosphere, that forms peroxy radical. Now, this peroxy radical is far more active than this R radical. Now, this peroxy radical then further abstracts one hydrogen or abstracts hydrogen from the other part of the rubber hydrocarbon or from other rubber hydrocarbon molecules that form by abstraction of that hydrogen from rubber. This peroxy radical forms hydroperoxide. This is again more reactive, more harmful than this R radical or peroxy radical. So, what happens? It forms hydroperoxide as well as generating one more free radical. So, what happens? There is a chain of reaction which is initiated over here, that gradually increase in rate and increase in concentration of these radicals, and that leads to breakage of chain scission, breakage of polymer chain, rubber chain with free radical formation. If this is if this occurs, then what happens? Ultimately, in a short period of time, the properties or the mechanical properties or any other properties of the rubber product will be reduced, or that product become useless. Now, this is the basic, very simple mechanistic view of degradation of rubber. Now, in order to prevent prevent that rubber product from such degradation, if some anti-degradant of AH type, anti-degradant, this AH represents one anti-degradant, or it can be antioxidant, or it can be antioxidant, etc. So, that antioxidant, anti-degradant will react with this free radical produced over here, like this R radical, by supplying hydrogen from its backbone to this, to stabilize this R radical. That means, it becomes RH, that means, RH has been regenerated. So, even if some free radical is created, this antioxidant will convert, it will revert back to a rubber hydrocarbon, creating a new radical. Now, this radical is not harmful, this is harmless, because the structure configuration and this formula of these compounds is such that electronic configuration of this radical is such that this free radical is stabilized. That means, this stabilized free radicals is not that reactive as the reactivity of R dot, RO dot or ROH, etc. So, this is not harmful, this is harmless. What happens in the next other cases? So, there are R dot, there are RO dot peroxy radical, that also be taken care of by this anti-degradant, forming this peroxy hydroperoxide and A dot, and again hydroperoxide will be also be converted to other harmless fragments, FRAGS is wrong over here, harmless fragments. So, this is the basic mechanistic principle, mechanistic way how this anti-degradant functions. Antioxidants, examples of antioxidants are hindered phenols, means phenol is this, the formula of phenol is this, OH, phenol. Now, if it can break over here forming free radical, that free radical will be stabilized with the aromatic phenyl ring. So, phenol is a good antioxidant or anti-degradant type of thing. Now, this is hindered, this hindered means this is connected to some bulky groups, bulky organic groups. So, that kind of phenol derivative is known as hindered phenols or aminophenol. That means, there can be some amino group. Now, having this amino group NH having lone pair. So, this can also prevent degradation by breaking of here, and when it is connected to some such type of phenyl ring. So, that will create stabilized free radical. So, amino phenol hydroquinone phosphite, this is PHOSPHIT phosphite phosphide or diphenylamine or naphthylamine or phenylenediamine. Many antioxidants are available in the market, commercial antioxidants are available in the market, and these are commercially used for making commercial rubber products like tires, tubes, hoses, beds, different or conveyor belts, etc. These antioxidants, any of these antioxidants are used. Now, there is one antioxidant made by Bayer, Germany, that is mercaptobenz imidazole. The formula of this mercaptobenz imidazole is this. This is mercapto. This is a very good antioxidant as well as antioxidant, mark 2 MBI or Volcanox MB. This is in other way it is known as MBI, mercaptobenz imidazole, or the company's name is Volcanox MB, chemical name is mercaptobenz imidazole. Examples of antioxidants: dialkyl phenylenediamine. Here is no scope of detailed description. If somebody wants to know details, he is referred to a book by Rubber Handbook by W. Huffman, excellent book on polymer rubber additives, additive chemistry is excellently described, exhaustively described in this book. So, different types of examples, apart from these examples, few examples mentioned over here: dialkyl phenylenediamine, nickel dibutyl dithiocarbamate, or waxes, even say paraffin wax, microcrystalline wax. These are also used as anti-ozonants, because if wax is used as an additive with a rubber compound, what happens, that is blended with rubber, then slowly these wax molecule, these are basically hydrocarbon. So, that blooms or diffuses to the surface and forms a very thin layer of coating over the rubber product. So, that is wax is saturated. So, that saturated thin layer coating prevents the ozone entry to the vulcanized rubber surface. So, that prevents degradation by the action of ozone. So, other than those additives, say processing aids, accelerators, cross-linking agents, accelerators, accelerator modifiers, and stabilizers, there are other miscellaneous additives which are also used for making rubber products. So, these are coloring materials, so these are pigments or dyes, mostly these are pigments to develop attractive color to bring aesthetic appeal to the rubber product. This can be yellow colored, this can be red colored, this can be brown colored, this can be green colored, this can be blue colored, whatever color is required, that can be developed by using coloring material. Sometimes cellular rubber products are used, rubber sponge or soft rubber cellulose, say cellular rubber products are used, that can be open cell sponge or closed cell sponge. These are made by using some blowing agents. The blowing agents can be either a gas or some gas generating chemical compound. Flame retardants, in order to impart some fire retardancy to the rubber product, some flame retardant ingredients are used, that can be chlorinated hydrocarbon, that can be chlorinated rubber, that can be some say alumina trihydrate, or some antimony compounds, or some phosphorus compounds, or some boron compounds. These are used as flame retardants. Some antistatic agents, in order to prevent the static charge accumulation over a rubber product surface, some antistatic agents are used, because if static charge is allowed to accumulate over a rubber product surface, what happens, that will attract dust from the air, and always a thick layer of dust will be deposited, will remain deposited. To prevent this dust accumulation through static charge developments, if some antistatic compounds like say quaternary ammonium salts are used, these are basically electrolyte type of compounds that helps in dissipation of the static charge which is generated over accumulated over the rubber product. Then abrasives for grinding wheels etc., grinding surfaces, for abrading surface, some rubber products, abrading rubber products are available. There are some hard materials say carborundum powder etc., these are used as abrasive material, abrasive additives. Then coupling agents, sometimes this your silica fillers are used or inorganic fillers are used. Inorganic fillers are used. Now, this inorganic fillers say for example, silica filler. Now, this is not compatible with hydrocarbon rubber, whereas carbon black I discussed earlier, carbon black is very good miscible or compatible with these hydrocarbon rubbers. Now, this carbon black can be easily accommodated by rubber, and that there can be interaction between the carbon black particle and the rubber molecules, whereas silica filler cannot enter into interactive physical anchorage or chemical anchorage to the rubber polymer chain. In order to use this silica filler as filler, silica filler is a reinforcing filler provided a coupling agent is used. What is this coupling agent? Coupling agent will have two parts. One is organic part, that means this your hydrocarbon part, and this is a polar part, this is non-polar, this is polar. So, what will happen? This if such type of compound is used with, or this is used with along with silica filler, the silica particle will be covered by these molecules like this. So, silica particle will be interacted with this polar group of the coupling agent, and this rest of the part of this your coupling agent will interact with the polymer chain. So, that way interaction between the silica filler will be developed through this coupling agent. This is nothing but a mediator or marriage maker. This is known as coupling agent. So, for example, for silica filler say Si69, this is a basically vinyl triethoxysilane. This Si69, the chemical name of this Si69 is vinyl triethoxysilane. This vinyl triethoxysilane is used along with the silica filler, then only this silica filler can act as a reinforcing filler in rubber product. These are something about miscellaneous additives. Then let us look into the. So, I have discussed till now about the composition of a rubber product, and I have explained the basic or fundamental roles of the ingredients or additives used in the rubber product, different types of additives used in the rubber product. Now, next step comes after compounding of such additives with the rubber, next step comes the fabrication and after fabrication or giving shape or shape of the item or manufacture or the formation of the product, then it needs to be vulcanized or cross linked. The product needs to be cross linked, which contains those additives along with the sulfur, etcetera, etcetera. So, till now the vulcanization is not allowed. So, after only this complete shape is given, then that is vulcanized or allowed to cross link. Now, there are various techniques available for vulcanization. That batch curing methods are involved, autoclave or steam pan at which provides a temperature of 140 to 160. Then gas curing, hot gas is used for curing. There can be a chamber which is known as oven, where the temperature is maintained, where the product can be introduced and slowly that will achieve the temperature of the oven and starts curing. Then hot water for curing, or sometimes some cold curing is done by using some chemical compounds. Then other than compression molding, say continuous vulcanization methods can be done, can be adopted. That means, product is being fabricated and continuously it enters into a system or device where the product is continuously vulcanized. Say for in case of cable, cable is made through extrusion process, and that passes through a high pressure steam chamber, where the rubber covering of the cable gets cured while it enters in between the entering and going out of the chamber, heat chamber or steam chamber. So, continuously it is entering and going out. During the residence time of that cable within the chamber, it starts curing and completes curing, then it ultimately goes out of the tunnel. Then there can be a hot air tunnel, there can be a molten salt bath, there can be fluidized bed, there can be continuous drum cure system, there can be also microwave curing. That means, there can be some microwave chamber. If that product is introduced in that microwave chamber, that will cause curing or vulcanization. Now, let us look into the mechanism of this vulcanization, brief mechanism of this vulcanization. Mechanism of vulcanization is very interesting. In this mechanism of vulcanization, you just have a look. I described about the accelerators. Accelerators, I mean to say, I can show you one representative formula. This is the formula of the cyclohexyl ring. This is mercaptobenzothiazole ring. This is the SN linkage, sulfonamide linkage. This is known as N cyclohexyl benzothiazole sulfonamide. In brief, it is known as CBS. There can be other accelerators. This is MBTS. There can be other accelerators. This is actually TETD, or if the ethyl groups are replaced by methyl group, there can be TMTD. There can be another very good accelerator, that is this is chlorite 18, this is thiocarbamyl sulfonamide, okay. Now, let us have a look into this mechanism. Now, accelerator here, this accelerator can be any of these compounds, Now, AC, here it is written AC, AC represents a part of this structure AC, this can be AC or this can be AC, this can also be AC, accelerated residue, this can be AC, this part can also be AC. Okay. So, this AC accelerator reacts with sulfur forming ACSXAC, this is known as monomeric polysulfide, and this monomeric polysulfide reacts with rubber molecule forming, that means this monomeric forming this sulfurated accelerated complex is attached to rubber forming a polymeric polysulfide. And when this polymeric polysulfide containing the sulfur and accelerator fragment interacts with rubber, that form a cross link bond SX, rubber to rubber. That means, you can have rubber chain, you can have SX, this kind of linkage. Now, look at this thing, this is an accelerator, say this type of chemical compound, CBS type of chemical compound. So, that reacts with MBT, MBT structure is not shown over here, earlier I have shown. So, that reacts with MBT, after breaking over here it forms MBTS, and MBT is released over here, either this can come over here to form this MBTS, reacts with sulfur S8 ring forming polysulfide, this polysulfide reacts with rubber to form this kind of linkage, this is accelerator moiety, this is sulfur linkage, polysulfide linkage, this is polymer chain, and ultimately it reacts with another rubber molecule forming this type of cross link. This is rubber molecule, this is rubber molecule, these two rubber molecules are linked with SX. So, this is a cross linked vulcanizate releasing this MBT. Now, you just look into the network, 3-dimensional network which is supposed to be formed. Now, while before vulcanization rubber molecules can be viewed in this entangled or coiled configuration, it is an unvulcanized network you can say. Now, on reaction with sulfur accelerator and accelerator activator, all those things, what happens? The rubber molecules are interlinked through sulfur, as I showed you the mechanism in the previous 2-3 slides. So, these red dots are actually the cross link or vulcanization points or nodal points, where the sulfur has interlinked to rubber molecules. So, these are sulfur cross link sites. So, now the more is the number of these sites, more will be the cross link density, less the number of sites, less will be the cross link density. More is the cross link density, stiffer will be the rubber product, less the cross link density, softer will be the rubber product. So, this is basically known as vulcanized network. So, depending on the cross link density, the mechanical property of the vulcanized network will be dependent. Having such information, let us look into this. Let us look into the effect of such vulcanization or introduction of cross link bonds into the rubber products on the properties. Now, this shows a schematic variation of the vulcanization properties. So, those properties can be tensile strength, those properties can be hardness, those properties can be dynamic properties like fatigue properties, that can be modulus, so and so with the change in cross link density. Now, you see the static modulus, this tensile strength and modulus, all these things which are measured using a dumbbell specimen by applying tensile force, that is known as static test. Now, in this static state one can get static modulus as well as tensile strength as well as tear strength, etc. And you see, with the increase of cross-link density, the static modulus increases, hardness increases, tensile strength increases through a maxima. That means, after reaching a maxima, then it decreases. If there is more cross-link density, it goes beyond some cross-link density, maximum optimum cross-link density, tensile strength decreases, whereas toughness also decreases at this cross-link. So, if you look into the cross-link density, this cross-link density can be taken as an indication of the properties level of that particular product. Which properties required, that this kind of schematic diagram will help to make a proper formulation. Look at the ultimate vulcanized network of the rubber chains. As I mentioned, when sulfur is used for vulcanization of dyne rubbers along with accelerator and accelerator activators, there can be a various type of different type of linkages. Now, this SX represents polysulfide linkage. Sulfur, actually this your sulfur remains as S8 ring. So, that decomposes to S8 this or S7 or S2 or S3 or S4 or S5 like this. So, that can break into sulfur polysulfides or monosulfides or even sulfur radical like this, that leads to form polysulfide, disulfide, monosulfide, some cyclic sulfide and cyclic monosulfide, cyclic polysulfide and some polysulfide accelerator complex. So, this is the nature of the vulcanized, nature of the cross-link in the our product. More is the concentration of this linkage, more will be the tensile strength, but poorer will be the aging characteristic. That means, this product will be, if there is more concentration of SX, there will be the life of the product will not be good, whereas less of SX, more of S2 and more of S, less of this sulfur SX, etc. So, that will be the excellent or efficient vulcanized network, because this cyclic sulfide SX or S or this kind of linkage that goes for wasteful utilization of sulfur, this is unrequired, this is to be avoided, whereas these two, presence of these two will be very efficient for making a stable as well as strong rubber product. Thank you very much.